All right, we're going to take a look at lesson 4.3. This is all about graphs of real-world situations. So we have three different objectives we're going to look at today. The first one is I can construct and interpret graphs that describe real-world situations. Second piece is I can learn the terminology of independent and dependent variables. And then our third objective is I can describe, read, and interpret graphs of real-world situations. We have quite a few vocabulary words that we're going to look at in this lesson, and I'll just quickly run through them, and then we'll talk about them as we go on. So we have independent and dependent variables, independent variable and dependent variable, linear and nonlinear, increasing and decreasing, rate of change, and continuous and discrete. So we can think of these vocab words in four groups of pairs. Rate of change is kind of all by itself, but independent and dependent variables kind of go together. Linear and nonlinear go together. Increasing and decreasing kind of go together, and continuous and discrete kind of go together. Right, and we'll get more into the specifics of those words as we go on. The first thing we're going to look at is linear and nonlinear. Linear and nonlinear. So we talked about this, I think at the beginning of chapter 3. So you guys might remember this, but what I want you to do is take a look at these 6 graphs, and this question exactly is in your check for understanding in that Google form. Let me just show you really quick so you know what I'm talking about. Let's see, let's go here, and then so from classwork, from the classwork tab in our Google Classroom, go down to week 15, and then under 4.3, graphs of real-world situations, we can click on this Google form. And after going through the different definitions, we can go down to this problem. This is exactly what I have written down, okay? So you can pull this up and just follow along, all right? So each of these graphs, we're checking to see if they are linear or nonlinear. Let's start with graph A. And what I want you to do first is pause the video. Pause the video and give it a try. There's 6 graphs here. This shouldn't take you more than a couple of minutes to just say if it's linear or nonlinear, okay? And then come back and I'll help you through it. All right, so let's go through the answers. So graph A is non-linear. Graph B, also not linear, non-linear. C is linear. So really quick, let's look at the definitions of linear and nonlinear. Really simple, really straightforward. Linear is in the shape of a straight line or represented by a straight line. And nonlinear is not in the shape of a straight line. It'll be curved in some respect, right? So D, again, nonlinear. E, linear. F, nonlinear. All right. Now, what we're going to look at next is a graph. This is our first example. And this graph, as we can see, is a nonlinear graph, nonlinear. And what it's telling us is the story of a leaky pool. Leaky pool. All right. And our first question in interpreting the graph, that's what we're going to be doing today, is interpreting graphs, is checking to see what are the quantities that are varying. In other words, what are the variables? What's going on within this leaky pool? And the easiest way to look, if we're given a graph, is to look at the axes. How are the axes labeled? Remember, this is our horizontal axis. This is our vertical axis, okay? And our horizontal axis is labeled time in hours. So that's one of our variables, will be time. And then our vertical axis is labeled as depth, So time and depth. Time in hours and depth in feet, okay? And let's talk about how those two variables relate to each other, okay? And this is when we're going to start talking about independent and dependent variables. So an independent variable is something that doesn't rely on anything else. Dependent variable is something that does rely on something else. So this first piece, we're looking at what variable is a function of the other variable. You know, that's kind of like super technical term. So let's just think about it a little bit. So we have the depth and we have the time. Think about, can you control time? Can you make it go faster or slower or backwards or forwards? Unfortunately, no. No, I don't think so, unless you have superpowers that you haven't told me about. But what about the depth of the pool? Is that controlled by something? Is that dependent on something? Yeah, it is. Because it varies with the amount of time that's passing. Okay, so as time passes, and I'm specifically looking at this graph, right? So as time passes, that means as we move to the right on our horizontal axis, as we move through time, the depth of the pool is changing. This time piece is totally independent of the situation. It doesn't depend on the pool. But the depth of the pool depends on how much time it's been sitting there. So this piece, I'm looking for the depth of the pool is a function of time. The depth, this is just another way to say that, the depth depends on how much time has passed. So again, that time piece will be our independent variable. Another way to think about our independent variable is our output, or is our input. It's our input. Another way to think about that is it's our x value. It'll be on that x-axis. But in this situation, it's going to be time. Time is our input and is our independent variable. Then depth will be our output and our dependent variable. In other words, it's along the vertical axis or the y-axis. Okay? That's a lot of information. It's okay if you're kind of still struggling with it. The big main takeaways are that the output, the dependent variable, and the y-axis are all kind of meaning the same thing. We're talking about the same thing. And then the input, the independent variable, and the x are, again, all talking about the same thing. All right? So now what we're going to do is we're going to practice using some of our vocabulary. So And we're going to do that by describing what's happening in this graph. So I've broken this down into 3 little chunks. This is our first chunk here, between these 2 points, the interval between those 2 points. The second interval would be right here between these 2 points. And then the third is right here, between this point and beyond. Okay? So in this first section, we start up here at 2, and then we end down here at 1. Okay? The starting time was at 0. The ending time was at 6. So I'm going from t equals 0 to t equals 6. And during that time, the depth is decreasing from 2 to 1. So in an interval of time, I shouldn't say time, in an interval of along the x-axis, another way to think about that is the domain. So in an interval of the domain, if the y values are changing up or down, that tells us if something is increasing or decreasing. I just made that way more confusing than it needs to be. I think you can clearly see that between these 2 points, that graph is decreasing. It's going down, right? Very straightforward. But a lot of the technical terms can kind of get in the way, as you might tell. So again, from this point to this point in this first interval, the graph is decreasing. Okay, and now in this second point, that goes from 6 to 12. Again, really straightforward. We're increasing. So from t equals 6 to t equals 12, the graph is increasing. And then what about from here on? We obviously don't know what happens after t equals 16, but what about the in between those 2 pieces? Again, it's pretty clear to see that it is decreasing. So t equals 16. That is decreasing. Okay. So if someone needed to know what this graph means, or they wanted me, if I was talking to them on the phone and I couldn't share my screen with them and I had to explain what my graph looked like, I would say that the depth of the pool is on my y-axis. The time is along the x-axis. Depth of pool is a function of time. The depth of the pool depends on how much time has passed. Time would be my input, would be my independent variable, is my domain. Depth of the pool is my output, is my dependent variable, is my range. All right? In between time equals 0 to time equals 6, so between 0 and 6 hours, my function was decreasing. So from the time I started until time equals 6 hours, the pool is leaking. The amount of water in the pool is decreasing. Then from time equals 6 hours to time equals 12 hours, from 6 to 12 hours, someone must have put a hose in the pool or something, because at that point the water level was increasing, the function was increasing. And then in my third interval, from 11 hours and beyond, the function slowly started decreasing again. The pool started losing water again, right? So what I want you guys to do now is to pull out your investigations. So you can go back to our Google Classroom, and in this assignment, there will be a Google Doc titled 4.3 Investigation. All right, and I want you to open that up. All right, let's start talking through the investigation. So again, you should have this document up. It is in Google Classroom. It's a Google Doc, and it should look like this. So the first step, what we're going to do is look at 3 graphs that show increasing functions. And we're going to answer 2 questions. What do those 3 graphs have in common? And how would you describe the rate of change in each of them? So I'm going to go back and do this on my piece of paper. So I kind of copied down those 3 graphs, and I'm just doing this on paper to show you that you can either type it in or you can write it down on a piece of paper and submit a photo of your work that way. There's plenty of ways to turn in the work you're doing at home. So my first question was, what do these 3 graphs all have in common? So the graphs here all increase from left to right. I think we can see that pretty clearly. The graphs increase, or they rise. That's another good word to use. They rise. They rise from left to right. They go up. The slopes, or remember that's the same thing as rate of change. Slope is the same thing as rate of change. The slopes are positive, or I didn't mean to say that. The slopes are constant. They're constant, or they can vary. They can change. They can be different. They vary. But overall, here's where I wanted to write that. Overall, they are positive. Overall, they are positive. Okay. And in an increasing function, the y values increase as x values decrease. Okay? So now we'll do the next step. And what I want you to do is take a look at these 3 graphs and take a look at these questions I have written down, or the sentences I have written down, or the questions I have written in the investigation, and I want you to try to answer those 2 questions. What do these graphs have in common, and what do you notice about the rate of change, about the slope, right? So take a couple minutes, write that stuff down, and then come back. You can pause the video. All right, so in the decreasing functions, the graphs fall from left to right. They go down. And again, the slopes are constant, or they can vary, but overall, they are negative. Overall, they are negative. And just as opposite of up here, as the y values are going to now decrease as x values increase. And I made a mistake up here. I said the y values increase as x values decrease. That should say increase. As the x values increase, the y values increase. For an increasing function. For a decreasing function, as the x values increase, y values will decrease. So now what I want you to do is go back to your investigation. You should have these filled out with what we just talked about. And then in steps 3 through 5, we're going to use vocabulary to find and describe graphs that match each of these real-world situations. So first thing we want to do is step 3, where for each situation, we're first going to determine the quantities that are varying. So what are the variables? And then we're going to match each situation to one of the graphs, okay? 2 of the graphs will not be used, right? And you can choose to do this either by just writing down on a piece of paper, you know, situation A, variables are this and this, and it matches graph whatever. You can write that all down on a piece of paper and submit a photo, or you can choose to go to this linked Google slide, and I have all the situations written down over here. And then once it finishes loading, yeah, here it is. All my graphs are over here in a pile. So what you can do is you can read through this first situation and then kind of start sorting through the different graphs to see which graph represents this situation. And simply pull over the graphs so that they match the situations, okay? And again, 2 graphs will not be used. There's 4 situations and 6 graphs. So 2 graphs are left over. Okay. So I'm going to do the first one with you. Okay. I'm going to do the first one with you. Let's go back to our investigation and we'll start doing it on here. What I want you to do, if you are using that Google Slides, I want you to write down the variables down here. Okay, so for situation A, I'm still in that. Oh geez. In situation A, I need to get out of here. Situation A. Situation A. There we go. Insert table. So situation A, how many times do I need to say that? Come on. It says, during the first few years, the number of deer on the island increased by a steady percentage. As food became less plentiful, the growth rate started slowing down. Now the number of births and deaths is about the same. So my first question is, what quantities are varying? What quantities are varying? So think about the numbers here and how they're changing. What are my variables? This first piece kind of gives it away to me. During the first few years, that means that we're looking at time. As time goes on, something else is changing. So time, I think, is going to be one of my variables. And then definitely my number of deer is my other variable. Although now I'm reading it, and maybe food could also, no, it's definitely time and number of deer. Time and number of deer. Time, anytime we use time, it's going to be our independent variable. So time, whoops, geez Louise. Time is my independent variable, and number of deer is my dependent variable. Now what I'm going to do is I'm going to look through my different graphs, and I'm going to do this on my slideshow. So I'm going to look through my different graphs and try to figure out which graph represents that situation, the situation of the deer on the island. So at first they're increasing. So the graph is rising from left to right. And then as food became less plentiful, so at a certain point in time, the growth rate started slowing down. Slowing down does not mean decreasing. It does not mean stopping. It just means the slope became less steep, okay? And then now the number of births and deaths are about the same. Okay, so it seems like it's going to be increasing and then kind of flatten out. Increasing and then flattening out. So graph 2 looks like it might be an option. Definitely not graph 6 because that's decreasing. Same with graph 4. Graph 5 looks pretty good. And not graphs 1 or 3 because those increase and then decrease. And I'm looking for something that increases and then just flattens out. And so think about the major differences between these two graphs. Graph 2 is a linear graph. Graph 2 is a linear graph. Graph 5 is non-linear. So something about linear graphs is that they will always have a constant rate. That's what makes them linear. That's what makes them a straight line. Non-linear graph is something a little more fluid, like the birth or death rate of deer. That's not something that's going to happen on a constant basis all the time because it's kind of random, right? Yes, deer live to be a certain age and the amount of food is, it's all affecting it and there's reason behind it. It's not totally random, but it is a little bit chaotic. It's not something that we can just easily predict, and it's not something that happens constantly. Therefore, it's going to be graph 5, this nonlinear graph which increases and then starts kind of puttering off and then flattens out at the top, right? So what I want you guys to do is continue doing that with these next 3 situations, okay? Where you go through and you first identify the variables, the quantities that are varying. And again, you can record them down here. I'll make little boxes for you. And then go over to your Google Slides and change the graphs around so that the graphs match the situation. All right. And then the 4th and final step of the investigation is going to be you can choose one of the situations, one of those 4 situations, and describe its graph. Describe its graph. So use words like linear, nonlinear, increasing, decreasing, rate of change, maximum, greatest value, minimum, least value, and explain why the graph matches the situation. All right. So I'd suggest that you pause the video now and complete steps 3 and 4 of your investigation. And then come back and we'll continue going through our notes for lesson 4.3. All right, let's move on to, this is one of the questions in your check for understanding. What are dependent and independent variables? So variables refers to that it's a quantity that is changing. A dependent variable relies on another variable for that change to happen. So really it relies on another variable, where independent variable does not rely on anything else. Our dependent variable is always going to be our output, and it's usually denoted by y. Our independent variable will always be our input, and it's usually denoted by x. Okay? The independent variable is going to be on the horizontal axis, and the dependent variable will be on the vertical axis. Vertical, horizontal. Okay? So now let's look at another example. So we have this graph here, and we have 4 questions to answer. Where is the function increasing? Where is the function decreasing? Where is it linear? Where is it nonlinear? And we're going to use a specific type of notation to tell us the different intervals, okay? So we use this in that first example where I had, you know what, never mind, scratch that. Let's just name these different intervals. So I have interval A, interval B, and interval C. Interval A, let's call this X, and let's call this Y. Interval A goes from X equal to 0 until X equal to 1.5. So from 0 to 1.5. Interval B goes from 1.5 to, what is that? 3.1, 2, 3? No. 3. It's going to be 4, so this would be 3. I don't know what that is. Let's call that 3. Let's call that right around 3. Okay? So B is going to go from 1.5 to 3. And then interval C goes from 3 to 4.5. Oops. Okay, so these different symbols, you'll learn more about those in chapter 5, but these are inequalities. I'm sure you've seen them before. And when we have this triangle, kind of almost triangle shape, and the line underneath it, what that's referring to is less than and equal to. Okay, so we're saying when X is greater than or equal to 0 and less than or equal to 1.5. So on a number line, it would be from 0 to 1.5. So anywhere between here and here. That's what this is talking about, okay? It's just naming this interval when X is between 0 and 1.5, when X is between 1.5 and 3, when X is between 3 and 4.5, okay? And that's going to give us a way to tell which interval the function's increasing, decreasing, linear, or nonlinear on, okay? So our answers to these questions are going to either be A, B, or C, okay? Or A and B, or B and C, or something like that, okay? But it's going to be that A, B, or C. So I want you to pause the video and give this a try. Look at the graph. Where is it increasing? Where is it decreasing? Where is it linear? Where is it nonlinear? Give that a try, like I said, and come back when you're done. All right, let's talk through this. So where is the function increasing? Where is it rising? Well, that's between here and here. So in intervals A and B. Another way to say that would be from 0 to 3. And where is the function decreasing? Well, it's decreasing right here in this portion. So that's in interval C, or from 3 to 4.5. Where is it linear? So where does it look like a line? That would be right there. It's straight right there. So that would be in interval C again from 3 to 4.5. And where is it nonlinear? Well, that would be in this curved portion. So intervals A and B from 0 to 3. All right. Now let's take a look at this graph down here. So this graph represents daylight hours throughout the year. So in the northern hemisphere, from the winter solstice until the summer solstice, So that's from December 21st to June 21st, daylight hours increase. And then from June 21st back to December 21st, or I guess December 20th, the daylight hours start decreasing. So we have the longest, the most amount of daylight hours up here during the summertime, and then the lowest number of daylight hours during the winter times. This graph is an example of something that is continuous. That means that the range, so the X or the Y values, the range, how much it increases and decreases, there's no breaks in that. There's also no breaks in the domain, so the X values. Okay, so domain and range do not have any breaks or holes. That's what that means, continuous. Just think about it like, you know the word continuous. Continuous, it means fluid, it means complete, it means there's no breaks in it at all, okay? So no holes or breaks in the graph, right? All right, and then this word discrete refers to graphs that that have quantities that must be whole numbers, okay? They involve quantities that are counted or measured only in whole numbers. So in actuality, so along the bottom here, we have number of days. Is there such a thing as like the 38.75 day? No, there's only the 38th day and then the 39th day. So in reality, this should be kind of broken up into like really finite pieces and have it just be plotted points along each day. But it just looks better and is a little bit more pleasing to see the graph as a smooth, continuous line, which is why we drew it that way. Another example would be in situation A when we were looking at the number of deer. There's never going to be a half of a deer. There's only a whole deer or no deer at all. So those are examples of discrete functions, discrete situations where involves quantities which must be measured in whole numbers, right? All right, so let's take a look at, we have a few more questions. These are all questions in your check for understanding. Okay, first one, how do increasing graphs differ from decreasing graphs? We went over this in the investigation, in step 1 of the investigation. Increasing graphs rise from left to right. Decreasing graphs fall from left to right, right? Overall, the rate of change or the slope in an increasing graph will be positive. Overall, the slope or the rate of change in a decreasing graph will be negative. What kinds of situations are represented by a linear graph? I talked about this a little bit in step 3 of the investigation. A linear graph is going to be something that has a constant rate of change. These are usually like fixed situations, really controllable situations. Something that is nonlinear has a varying rate of change, okay? And discrete functions, I just spoke about that. The discrete functions are functions that involve quantities that must be measured in whole numbers. Must be measured in whole numbers. all right? Okay, so now you have these 3 questions. These are all in the Google form, the Check for Understanding Google form. So I just went over these questions. Make sure you answer those. For this question, what I want you to do is read through these different situations and try your best to create a graph on your own. Create a graph for each of these 3 situations. It shouldn't take you super long. It's just a sketch. It doesn't need to be perfect, but I want you to label the axes and then draw the graph and then upload a picture into the Google form. So you can do that by adding a file, and then what you would do is you'd take a picture and then you can email it to yourself, or you can upload it to your Google Drive and then then you can drag that file into here and upload the picture that way. Or if you're doing this Google form from your phone, then I think it would be really easy to take a picture from your phone. It would be saved in your photos, and then you could upload it directly to here. All right, one last question. If I walk from here to there and back again, what can you say about the function that describes my location in terms of time? Right? I want you guys to think about that for a second and then come back and I'll go over it with you. All right, so the dependent variable in this situation is going to be location. The independent variable, as I mentioned, is going to be time. Time is always going to be an independent variable because we can't control time. Time just, as they say, time marches on. It doesn't rely on anything else. The function is going to be continuous because there's no gaps in time. Time always just keeps going. If I walk at a constant rate, the function will be linear. But otherwise, if I walk at a varying rate, then my function will be nonlinear. If location is measured as distance from a starting point, the function increases as I walk away and then decreases as I walk back. All right, that takes care of all of your work for 4.3. I hope this video was helpful, but if you have any other questions or need me to clarify anything, please let me know. Okay, I hope you guys are having an awesome day and to talk to you soon.